but it's like with the basic programming, there's something that you're not catching up to. We'll make sure to get caught. Yeah, but they can work with it.
Other questions? You want to go down that list, Rosie?
Yeah, I'll make it super fast.
And like I said, that we're being real, hard butts about the stuff on the list because this is federal funding, so taxpayers' dollars, and we got to make sure that we spend it right.
Like very fast, and we'll collect these at the end of the morning. Just make sure you initial them. We want to go over a few things to make sure that you've heard them again, even though you received them in your packets. We expect you to follow all rules and guidelines. There was a code of conduct, a research agreement that you signed in your package. Please look that over again and make sure you know exactly what you committed to, because there are obviously consequences if you don't follow the code of conduct and the UT student honor code, which you can find on the main webpage for UT Austin. So I think Austin has a social life, but you're here primarily as a student, and as long as you can balance your personal time with your time committed to your researcher and their work, that's really, we expect you to be very professional, on time. That goes back to like the additional expectations of punctuality. If you have an appointment set up with your researcher, we want you to be on time. We expect you to be on time for the rest of this week and anytime we have a scheduled presentation or workshop. The dress code, many of you asked. I think I replied all. We're very casual around here. It's really hot and humid over the summer. If you do have an appointment with your research team or a meeting, we do, just encourage you to wear maybe a collared shirt. I'm not sure what the culture is within their groups. You'll find out after your first meeting, but just something to consider. The time commitment. We're paying you, you're getting a nice stipend for your room and board. It's a nice deal. I wish I was a student sometimes and had that deal myself. But we do expect you to work, this is like a full-time job. And one thing you'll learn is that you don't clock out necessarily at 5 p.m. Some of your work you're going to be doing independently on your own. You'll have to find a place. If you need space, we have space here at TAC. If you're willing to take the shuttle, and there are some considerations with the schedule for the UT shuttle, but there's places on campus, places where you can plug in. There's a library, there's the computer science building, which has some awesome space. But we definitely expect you, to complete your projects and for your research or mentor to rave about the quality of your work. And oftentimes we know that doesn't happen with just 40 hours per week. We're not asking you, or your research team to slave drive you, but we definitely want you to perform at the best ability that you can. And if that means past 5 p.m., you don't have to tell us. We're not going to check in on you. You don't have to clock in and clock out, but just know that our jobs sometimes go beyond the Monday through Friday, 8 to 5. That said, staying in Austin, again, we expect you to stay here in Austin with, for the 10 weeks. We would hate for you to have a family emergency. You have to leave and not even make it back on time, by Monday for a training or a meeting or to continue to do your work. So if something arises where you have a special situation where you absolutely have to leave Austin, we know as soon as possible. Pay dates are now, and the disbursements have now been updated on the calendar, so you can see that your first pay date, let's see, is on the 11th. Okay, that's next week. So we don't expect you to disappear that weekend. But you can see the disbursements there, and I'm more than happy to email them to you again if you need them. The training schedule is included in this packet, so again, please be punctual. The STEM communication workshops, this was something very different than what you probably find in other REUs. We think it's extremely important to be able to develop, communication skills so that you can share with the general audience, whether they're researchers or not, what it is that you're doing. So for that, we will be supporting you in helping you create a website for yourself so that you can share with your friends and your family, and you can keep them updated with all the neat work that you're doing. We also want, these are part of communication skills are important to have also because we expect you to consider, signing up for a poster presentation at either XC14, and we'll talk a little bit more about that, or at the annual supercomputing conference, which is coming up in November 16th through the 21st. And that's down here, and we'll talk about it a little bit more. But these are opportunities for you to really communicate your research and also build your resume. Someone mentioned that earlier, it really helps. There's also a math camp that we signed up for. So someone reached out to us, and they were looking for role models to talk to young kids. This is a part of a camp for students. It's coordinated by a community college, Austin Community College. So I'll be working with you, coordinating transportation. But we'd like for a few of you to come out and maybe talk to a few 6th through 8th graders about the work that you're doing. And these kids always get real motivated and inspired by, students that are young looking, like yourselves, that can tell them what research is, because oftentimes the kids, they don't have role models or don't know much about research. So it'd be cool to get out there and talk to them about that. And preparation for that, for a workshop that we have on the 27th, actually it begins today. So surprise, you'll be doing some interviews, just 5-10-minute interviews with our multimedia producer, Sean Cunningham. And I will, we don't have a whiteboard here, huh? I will let you know, I have the schedule here, when to speak out or when Sean comes out to get you. And again, he's just going to ask you a few questions, 3 questions. Don't get nervous. There's no right or wrong answers. It's just to prep material for the workshop on the 27th. ID Center, so none of you have your UT ID except for the UT students, right? So today, make sure as soon as you get out of here that you go to the Flan Academic Center. It's right next to the tower.
Right next to it.
And there's no way of getting lost. It's on the 1st floor. You'll need to get your ID, and there should be $425 dine-in dollars on that ID card. So yours should work effective today, and I'll go ahead and email Lisa to make sure that Emily and Sterling to get that. Summer Research Scholars Packet and Welcome Reception, I'll pass those out. And that's, again, another great support program that we have here for all of the undergraduate students doing research at UT Austin. So this includes the students from other RUs, including, I know the Cockrell School has, I think, 1 or 2 RUs, and the Environmental Science Institute, those are just some that they sit across the street, so that you can network and meet other undergraduate students doing research at UT. Conferences, we can talk about these later. We need to talk about the XC14 conference in Atlanta, Georgia. That is on your calendar. Sam will be actually working, he'll select, from what I understand, Sam, so you will select about 5 projects. I think they reserved 5 seats for us. Yeah. So if, for example, let's say, Sterling, you applied, you submitted, the application for the travel grant. If you get notified or anybody gets notified that you've been selected before Sam, or even if Sam contacts you, then you still get to go as a participant. If you get to present your poster, the poster presentation is just 1 day. It's an event for about 2 hours, and we can talk more about, how many of you guys have ever attended a conference where there's poster presentations? So not all of you. So we can talk about that later, so that you know what to expect. We can have a whole conversation or lunch just talking about Exceed. Same thing for the supercomputing conference. I'm going to email you a link to an application later today. That deadline to apply is June 15th. Please don't miss it. It's a great conference. It's probably it is the biggest conference. It's an international conference. We get folks from around the world that attend. How many attendees?
10,000.
10,000. Each year it's somewhere new. John Lockman actually here for the last 3-4 years has coached a team of 6 members from UT Austin that compete in a student cluster competition. And it's a 48 or 72, 72 hour competition. He can tell you a little bit more about that later, but for the last 2 years, Texas has won the overall big win, and that was a pretty big deal even last year when we beat the team from Taiwan that had won consecutively for the last 2 years. So we win this year, this would be the third consecutive win, and we would be the only team to have 3 consecutive wins.
So they're world champions in this.
Yeah.
It's a world competition.
Yeah. So you're in good hands with John Lockman here. And this scholarship, whether you're working with us, you know, this is post-TAC, this is for your future, please apply. Ritu, who's going to be coming in to do some training as well, was actually a student participating in this, it's called Broadening Engagement Program. And she mentioned to me that the reason she still actively participates on their planning committee and tries to get her students to apply is because through this cohort, through this team, had she not attended, she would have never gone into you know, scientific computing. So she's very vested and believes in what this program does, and I'm a big fan, I'll tell you. That's it. University Health Services. Sam, we did pay for you all to seek services here at the campus. So we can.
Yeah, we pay so you can have access to it, but you still have to pay. I think it's like $60 a visit, and you have to check and see what they take for your insurance. But if we didn't sign up, you couldn't even use it. You know, so it's just, and there's some other things that we'll find out. It's like they have like convenient walk-in stuff. So you don't have to necessarily go to the clinic. But if you're on the list that actually have permission to use it, even though you still have to pay for it at that small rate. Yeah.
And there is a reception. Tomorrow's the last day to RSVP for the reception from the Summer Scholars Program. I just want to make sure because I'm going to pass out those packets that go over them. So you can definitely review those later. We're going to start.
Yeah, we need to keep going for.
Training time? Yes.
So some of these guys don't have an ID yet?
Oh, so they're going to get one today.
Right, but there's temporary wireless right here.
Thank you, Dean. Okay. So just,
The ones that aren't UT Austin will be one of those.
okay. So you're not UT Austin. Okay. And Zach, you're UT Austin, right? So you go by Sterling. Okay, just bring it with you when you go to the academic one center. So they close at 6 p.m. So you should be there. Just go directly there when you get off the shuttle later on this afternoon. So we're ready.
Their EID.
Any questions?
Their EID may actually work.
Oh.
Even though they haven't been the EID center.
Okay. So your EID, do you all know your EID by heart? Okay. No?
Yeah, try that first.
Okay, try that first. It might work.
For wireless access.
Yeah. All right, I will try to get back to go to lunch with you. If I don't, I'll see you later. So, good luck. It's going to be grueling.
That's good to know.
What now? Isn't that last time, maybe? Mercer. Yeah. Yeah, I've lived in Fort Worth a couple times.
Not much there.
Beaches.
We go by Zach. I would make sure of that. Right.
Yep.
You go by John. Yeah, definitely. Sorry for all the talking. We usually don't talk this much. Okay, if you all have any questions for John, Joe, Arnold, Vicky, okay, Ben. Okay, so there's one more student that's not here today, Brittany Crockett. You'll meet her tomorrow. She's actually part of a research team with the petroleum engineering and geosystems, I think. And they have their own research funded team. So she had to attend a mandatory orientation today. So if you see a new face tomorrow, she didn't ditch us, but she'll be here tomorrow. And I think, who's going to be gone tomorrow and Thursday? John, you'll skip out early, right, for those meetings? You have.
Are they here in this?
No, I'll let you know where they are. You're going to have to take the shuttle back. They're just from 2 to 5, right? 2 to 4, yeah. And I'll find out. You can just email Ben and ask them exactly where. Yeah. Have you all had a time to tour UT on your own? Well, those non-UT students. Yeah.
Right around.
What was that?
Or just dragging around.
Okay, very cool. Very cool. Your parking. I know, John, you're the only one that has to get that.
I'll just see if I can. I'm trying to disability one.
Okay.
It's one set.
Okay, cool. Yeah, that's the closest, garage. Otherwise, everything's a hike.
Yeah.
But, all right. Any other questions? I know you have some questions. No?
I have like a general question. It's like, you know, you guys went through but the calendar is like every Friday.
Okay, yes. So, yeah, you are responsible for your own schedule. I mean, you can work out those details with your UT researcher in terms of, where do they want you to work, and how, every day do they meet you at a certain place? Like, those are really important questions to ask. Because a lot of the times, or your graduate research, who you're going to be working closely with, and I'll email you again. I'll email you individually today who your graduate mentor will be. But oftentimes, and Sterling, you work remotely, right? When you were with Yakup, or did you spend some time working here at TAC?
I was in class.
Oh, okay, okay. So you spend more time after class. A lot of times, I mean, we have space here, but you'd be surprised. A lot of researchers work on their own from their computer. You're responsible, so you squeeze in your lunch breaks, your gym breaks, please. If you need exercise to stay safe and healthy, strongly recommend it. And if there's anything the questions that you have, about your schedule, you'd probably be better off asking your graduate mentor if he's or she is more accessible. On your research team is aware that you're going to be having these required workshops on Friday to learn more about BIS and to hear presentations from some of the researchers like Dr. Pierce who's here today. And so that's fine. You'll still that's considered part of your work schedule. We don't expect you to go home after 4 or 5 p.m. I mean, you're on your own doing your projects. So yeah, definitely, we're not going to be supervising your work. It's going to be your faculty researcher. Yeah. Nope.
What do we explain our pilot training?
So that should be already set up for you, and I'm going to go ahead and email Lisa Diaz today with housing. She sets that up. She submits a request because you'll need high insurance to be able. I know that Karen Guard asked you that, but to be able to get it out of the dorms. Did anybody have trouble with your dorms? Like, did they get it out? Really? Oh, okay. Lisa's contact with housing. Everything else is good. Has anybody tried using their, homes with my just kidding. I'll give her Sterling or Emily when you try to, use that field for. What was that?
Should I be using the temporary?
They'll give you a real ID. Like an ID card when today when you go to the one.
And then we can use that to apply for the phone.
Yes. then you follow up with Karen and say, you have it. And then you can ask them when you get your ID just to make sure, hey, is this high insurance? We'll make sure. But I'll go ahead and go do CPS to make sure. So if she doesn't request it, I'll go ahead and request it. John, they're all yours. So Brian, I know you need a laptop, CD before. Which Brian? Oh, sorry, Zach. I'm gonna go up to Zach.
All right. Let's get this guy sharing. There we go. So, as I mentioned, my name is John Lockman. I've been here at TAC for, I don't know, 6 or 7 years now. I am a high-performance computing specialist here, and I also run our training program for TAC and for our larger national program through Exceed. So we offer a lot of different types of training, and it's kind of a new one for us, so hope you enjoy it. How many of you have already started using Linux? Hands. Use it a lot? Yeah, a little bit. Okay, so what we're going to do today for the morning session is we're going to focus a lot on Linux and just kind of the commands that you're going to be using, trying to get you familiar with how Linux works and maybe draw some correlations of how you already use it on your Mac. See, a couple of you guys got Macs, and you do know that a Mac OS is actually Unix. Yeah, so it's actually built on top of Unix, and that's why it's kind of very hardened, and you don't see a whole lot of issues with it for the most part, right? It's a single operating system that they target with their special hardware. You know, and then you may see with Windows, you say, oh, it works better on this machine than this machine because it's kind of designed for more different types of hardware. So one thing that I like to always start this off with, because we are in the supercomputing world, that's why I say Linux in the real world, or you know, in our world. You notice when you came into this room, you probably saw the glass door with lots of Stampede over there. Lots of blinking lights, lots of cable, lots of noise. We'll go in there and take a tour this afternoon so you can check that out. But one of the things that we focus on a lot here is, of course, supercomputing and high-performance computing. And there is a measure out there called the Top 500. They produce a list twice a year of the largest or fastest supercomputers in the world. So just to get a feel for what do you guys think? How many of those do you think in that list of 500 machines, fastest in the world, how many do you think ran Linux? All of them? Most? Some? How about Windows? 2? What about Mac OS? Yeah. Okay. Well, about 97% of them are Linux-like or Unix. And I'll talk a little bit about the differences between what we say when I say what's the difference between Linux and Unix. But just a quick rundown: 92% of them are actually Linux. 4.8, almost 5%. 22 machines are actually Unix-based. We have a handful of mixed machines, which means that they're probably dual boot. You know, they can boot into Linux or Windows or something like that, because we do have 2 Windows machines up there on the top 500 list. They do participate, and 1 BSD, which would be kind of your Mac OS style. So just a little history to kind of bring you up to speed to where we are today. Unix is over 40 years old. Oh, thank you. It's been in development for a very long time. It goes all the way back to 1969 with a group of Bell Laboratories who were trying to figure out a way that they could design an operating system that could run on different types of hardware. The original Unix operating system was written in just assembler, so it was a very low-level language machine. And the early installations in '72 had over 3 users. I mean, amazing multi-user system, right? And this whopping huge 500 kilobyte disk. You look at these numbers now and go, really? That's the disk that they had, but this disk was literally this big, 500K, and 3 users. We get thousands of users on Stampede now, so it's a very rich multi-user environment. And right here in the picture here, you can see this is the DEC PDP-11 in 1972 with their little teletype. It's surprising it doesn't have a big wheel or something to steer it, but yeah, kind of goes back. So that's kind of the Unix background, right? It came around because we needed an operating system that could run on different types of hardware. Back then, you would find that people manufacturing machines would come up with their own type of assembler language that worked on that machine, and you couldn't really move code around. If you wrote something for this piece of hardware, that's the only hardware it works on. So Unix was kind of this idea that we could build an operating system that could run on different types of hardware from any vendor. The only problem was, of course, because it was developed at a laboratory, Bell Labs, Unix was expensive. It cost money. You had to license it if you wanted to use it on your systems. In the 90s, we saw Microsoft DOS was kind of the mainstream operating system that people were using on their PCs in businesses and things like that. And there was a group of people who got out there and were really trying to make this open source version called Minix, but it was kind of a big failure. It wasn't really a full port. Not a lot of it worked. So people just kind of abandoned it and kind of said, you know, we really need an open source solution. We need something that's out there for everybody to use that's free. So in the 90s, we have two very important people that kind of started this. Richard Stallman, father of the GNU project. Here you can see him playing his flute to his computer or something. He's an interesting character. I recommend you take a look for some YouTube videos of his talks. He's been here to UT campus a couple of times too. Very interesting guy, and he has a lot of interesting ideas, especially in terms of the open source movement and what free software really means. The other guy over here is Linus Torvalds. He is kind of the father of the Linux kernel itself. He wrote the biggest part of Linux that we use today, and he's still an active contributor. So I've said Unix and Linux, and we've kind of flipped back and forth, but what really is the difference? Linux is a clone of the Unix operating system, but it was written from scratch. So it doesn't use any of the code that was written to write Unix. Like I said, the kernel was written by Linus Torvalds, but he also has assistance from developers around the globe. And if you use the common naming convention, Linux is not Unix. That's kind of what that's Linux. So Linux is not Unix, but it is, like I said, a clone. Linus uploaded that first version, 0.01, back in September of '91, in a post onto a news group saying, "Hey everybody, I made this cool thing. I think it's going to be cool. Let's all play together." And he got a lot of people behind it. And a big part of that, of course, was Richard Stallman and his work in building the general public license, GPL, which is how all of the source code is licensed, making it freely available for anybody to use. You can resell it. You can make modifications to it. There's nothing closed about it. You can look at all of the code. And then now there's a large number of Linux-based distributions out there that are for sale. Some are free. We'll talk about a few of those that we use here. And of course, there's some, like I said, for purchase. And it's not because, well, like I said, they're all developed under this GNU public license to make it freely available. But what companies can do, like Red Hat, is they can package Linux and sell you a maintenance contract, meaning that the operating system is free, but you're gonna pay for help, basically. If you want to ask questions or you want modifications, things like that. That's kind of the beauty of the GPL license. So you'll see that there are a million different types of Linux, or flavors as they're called. And there's basically three main branches. There's Red Hat, Debian, and Slackware. And let's see if I can open this page here. You'll see this nice Wikipedia entry has this picture over here. And just to give you a feel for what I mean a lot, there are a lot of different branches. And we see that this here is the Debian branch. And if you come out here, you'll see all of the different historical Linux that have existed that were branched off of that original core. And so you see some of these have died off back here, and several of them are still going strong. So quite a bit of different types. There's the Debian branch. If we come down here, well, you get a bunch of random, they weren't branched off of anything, somebody just started it, and then they kind of died after a while. You have the Slackware branch, where we have, of course, lots of different Linuxes coming out of there. And that last one I wanted to show you was the Red Hat branch right here, which is where we spend a lot of our focus in the Red Hat world, because it is enterprise Linux, it's hardened, and we use on our supercomputers a branch here called CentOS. And on my laptop, I'll show you. I have a copy of Fedora, which is the upstream version of Red Hat. So one thing I'd like to give a little plug about the Fedora project. It is a project that I contribute to, and it's I think it's a great group of people. It's a project of a worldwide community of people who love, use, and build free software. That's kind of the easiest way to sum it up. It is a Red Hat sponsored project. You can check out their website at fedoraproject.org. And like I said, this is just kind of a group of people all around the world that are interested in Linux and how it works, and interested in building free software for the rest of the world to use as well. They have just 4 basic ideas about their group. Freedom. That's the first one, is that Fedora will always be free. But when we say free, we don't have this word in English. This is free meaning more like liberty, not price. Okay. So to understand this concept, you should think of free as in free speech, not free as in free beer. So that's kind of the open source side of it. Features is another big part of Fedora. So one thing that they try to do is they do a twice-a-year release, which means that we have developers all around the world that are actively trying to make new, cool tools, things that are useful to people. And what you'll find is that a lot of those projects that get completed get rolled into other flavors of Linux too. Network Manager, Pulse Audio, the automatic bug reporting tool. These were things that came out because the Fedora group is very interested in getting things out first, being quick about developing new tools and advancing Linux as an operating system. Another thing here is friends. So it is a worldwide community of over 25,000 people. They actively have hangouts and group meetings with people in all around the world. They do things like Fedora Days, where they'll go out to a university campus and just give out copies of the software on USB sticks or CDs, or just have signs and tell people about it, show people what's going on. And of course, there's more than just developers that are involved in the project. There's designers that do open source art. You of course have documentation and programmers. So I mean, you have a wide variety of things that you can help out with if you're interested. And the last part, like I said, first, they want to be first on innovation. They have this rapid release cycle twice a year, so that they're always trying to get out new stuff, making it cool, sometimes making people unhappy in making new things, but that's kind of a part of progress, right? So why do we care so much? Why are we using Linux? 4 main reasons. Performance. So as we've already seen, supercomputers generally run Linux, right? Reason there being it's a rich multi-user environment. We have thousands of people on our machines at a time. Functionality. Again, a number of the community-driven scientific apps and libraries are developed under Linux because it's open source and they want to be able to share it. So you have things like molecular dynamics, linear algebra libraries, Fourier transform algorithms. There's a ton of scientific code out there that's free for you to use because it was designed in this environment. And the last 2, flexibility or portability. Basically, Linux lets you build your own applications, and there's a wide array of support tools for you to use. There's compilers, there's scientific libraries like we talked about, there's debuggers, there's network monitors. If you can think about it, somebody probably already wrote it. And if not, you can start the project yourself and hopefully get some people behind you on that as well. So why is it still used? Well, over 40 years of development with Unix, and then we saw Linux come out in 1991. We have the academic tools, the system tools that are available to us. It's open source. We are an academic institution, and we do get money to build these big machines from the National Science Foundation, but one thing we don't get is money for software. So as in any situation, let's use the best tool that's available that is still free, and that's kind of where the advancement and development's been going. The system is very stable, so we don't do a lot of reboots or anything like that. You can make Linux extremely lightweight too. For instance, thank you, David. I have a Raspberry Pi here. Have you guys seen this before? So it's a $25 computer. It has this very small processor and an SD card that runs the operating system. So you can make the OS as small as you like because you really only need a core bit of information. And of course, like I said, we can just store it right on this SD card, and we have a full Linux operating system on a small card. I'll pass this around to you guys in a little while. And the last bit, of course, is easy development. I get a Linux machine, I can hop right on and start writing code. There's nothing that I have to, no extra pieces I have to buy to make sure that I can compile code or run code that I develop. And there's a ton of tools out there that can help you to develop these things as well. So a little bit on the basics, and again, as Sam said, feel free to stop me at any time if you want to ask a question or clarify something. We'll do a little bit of hands-on as this talk goes along. So I'll help you guys all get onto the machine. Everybody does have a login already. Is that correct? Everybody can log into the user portal. Does everybody know how to SSH to Stampede? No? That's okay. We'll go through that. So we'll cover a little bit of the basics, and then we'll get everybody on, and we'll start playing around here. So you have a command line. This is the easiest way to interact with Linux, especially when you're working on the supercomputers here. Basically, it's a terminal with text. We can open up editors. We can do all sorts of commands to show me what's in my directory or create directories. One thing to be cautious of: there's often no warnings. When you run a command, it doesn't, when I say remove a file, it doesn't go, are you sure? It doesn't put it in the trash bin or the recycle bin. It just deletes it, and it doesn't say anything. So you say delete this file, it says okay. So it's something to be cautious of when you're playing around. Like I said, there's typically no undo or warning when you're running commands. Your command line is actually running inside what's called a shell. And the user environment, this is the user environment that enables interaction with the kernel or the lower operating system itself. When we talk about the kernel, that's that piece I said that Linus Torvalds had developed. And what that kernel is that's the core of Linux that allows you as a programmer or a user to talk to the hardware. For instance, maybe you want to say, what are the files in this directory? You have a command called ls, we'll talk about that asks the kernel, hey, can you talk to the hard drive for me and tell me what's in this directory. You can think of Windows Explorer as kind of a shell in Windows, kind of a loose connection there, but similar. So it gives you a window into your machine. So how exactly does that work? Well, Linux has one kernel and one or more shells. So we can have lots of shells open at once, so many users can interact with the machine. Again, like I said, hundreds of people that are logged into Stampede right now, all running their own shell. And that kernel is just the core of the operating system. This is what receives tasks from the shell as you give it. Hey, tell me what's in this directory. The kernel says, okay, I'll go take a look at that and perform these operations for you. And that shell, again, is just that interface in which the user is going to interact with the machine. So you only have basically two things in Linux. Everything is either a file or a process. There are some things that are kind of magical in between, such as the proc file system, but we'll talk about that later on. Basically, a process is an executing program that's identified by a unique process ID. And one of the things you'll find as if you've done computer science or you start looking at things when we talk about operating systems, everything needs to be shortened to a 3- or 4-letter acronym. So process identifier, PID, and you'll see this repeated through lots of things because one thing you'll find as you start programming is you'll see that programmers are lazy. Okay, maybe not lazy, but they don't like to type a lot. So as short as we possibly can have it. And again, the processes, these are just processes that are short in duration. They can run indefinitely. So you might have a program like list, show me what's in this directory. It runs real quickly, comes in and out, and it's done. You might have other ones that run indefinitely, like a monitoring program or something that's making sure that your network traffic is working correctly. And I'll show you a couple of those right now, actually. So make sure everybody can see this. Big enough? People can read that? So let's say I take a look at this program called top, and I'll show you a little bit more about that later. But right now I have a process called top, and you can see it has a PID. So the process ID is 5514. Here's the program that I'm running called top, and again, it's running indefinitely until I quit out of there. So that's an example of something that might run forever if I always want to be monitoring my system, seeing what it's doing, finding out how much memory it's using, and all this kind of information. To exit the top program, you just hit the letter Q. A more simple program, maybe I just wanted to see what's in my directory. I can do an ls, and I see I have some files in here, some text files, some tarballs, and other directories, whatnot. So again, this is a program that just basically says, hey, what do you have right here? So that's a process. File is just a collection of data. I think everybody's worked with files before. Files can be created using your text editors. They can be created when you run a compiler. So maybe you have a piece of code, you run the compiler on it, and it creates a new file that's your executable. The kernel, again, is just responsible for organizing processes and interacting with files. So it's handling all that for you. The file system, communications in response to the calls that you make, and the programs that you run. So what does this shell do? Well, it tends to do 4 things repeatedly. It displays your prompt. It says, okay, I'm here, I'm ready for a command. It reads a command that you type. It processes that command and then executes it and then returns right back. So as in the ls example, I type ls, the prompt is just sitting here waiting for me to do something. I type ls, it reads it, it executes it, and returns my prompt, and now it's just sitting here waiting for another command. So again, our basic interaction is with Linux through the shell. This is how you guys are going to talk to the machine when you start hopping on Stampede and start writing some code or modifying code, whatever it is you're going to do. You're going to use a shell, and we'll more than likely have you guys all in Bash, and we'll talk about more what that means in a little bit. Your shell can be graphical. There's a thing called X Windows. So for instance, I'm running a Mac OS right now, which is a Unix, but I have a whole graphical interface, right? I can use a mouse, I can click on things. That's what we call a graphical interface. And then, like I showed you too, I have a terminal, so I can do this too. I can interact with the machine in multiple different ways. For remote access, though, okay, I'm on my machine right here, and that's fine to be, having graphics and showing a presentation and things like this. But when I'm remoting into Stampede, you'll more than likely want to use the text-based shell because you don't want to have to send so much information over the internet. And I guarantee you, it is slow to do a full X window session all the time. So we'll access all of these using a program called Secure Shell or SSH. And again, we'll get into that as we start doing as we start playing around here. So I want to show you how to open up a terminal. If you're using Linux, I have an example here for GNOME 3, which is a Fedora. Fedora is using GNOME 3 as its window manager, so that's its graphical interface. There's many others available, such as LXDE, Unity, all sorts of different window managers out there that you can play with. But in that system, you just hit the super key or the Windows key, and then type terminal, and you'll find the program. If we're in Mac OS, I like to use the Spotlight search because I don't know how to navigate through their amazing window scheme. So the easiest way to bring up the Spotlight search is to hit Command and Spacebar. That brings up your search over here. And if you just type the word terminal, you'll see that's the top hit right there. If I click that, now I have a terminal open here. For our Windows users, I can do that too. I have a Windows thing here. If I could type my password. So let me get logged in so I can show you. For Windows, you have two different options. One I tend to use a lot is PuTTY. There's also this program called Secure Shell Client, which does work as well. But again, like I said, I prefer PuTTY. You can download it from the internet. It's PUTTY, and you basically just click on this guy, and it'll open up a configuration prompt. And what you do is you say, maybe I want to go to Stampede. I'll type in my host name, do a shortcut here. I'll call J. Lockman, that's my username, at Stampede. So for our Windows people, have you downloaded PuTTY already? You already have a client? You've got it? Okay, cool. So you can just type in your username at the machine. Make sure the SSH is checked so that it's going through port 22, and you just click open. It'll ask you the first time you've connected to it. It says, hey, I don't know this machine. Are you sure that you're going to the machine that you want to go to? You can just say yes, because we know we're going there, and then you type in your TAC password. Yeah, you want to get everybody on? Yeah.
Download PuTTY on this computer, because these are ours.
Yeah, you should have PuTTY on there, actually.
Yeah, PuTTY's on. It's on here?
Yep.
Hit Windows key and just type PuTTY in.
If we're using it on this, how do you remotely access
Just open the terminal. You got a terminal already? Cool. Then just SSH.
Oh, I
Stampede,
understand.
yep.
Gotcha. Thank you.
Yes. We're going to get everybody on. Wireless.
That's already in there. Yeah, SSH.
Okay, this is your way down. This is actually your admin. No, just Stampede. Yeah, Stampede.tac.use.
Port 22, right?
And use your TAC password, the one that you created on the phone.
Yeah, so.
Ready? Okay. You can upload it to Word. Have you set up an account already?
I actually have that.
Jason?
Let's see. I'm not going to connect to the one that I have my machine. I have one on my computer and I'm under.
Okay. Let me just try that.
Okay.
Here, let me put it up on the screen.
You know the code. It's okay.
You can use the terminal there and then SSH.
Right, just press no or yes.
Oh, you're logging it, no, just say yes, so what you would say, yeah.
Okay.
You don't have to.
Oh, so that was just saying.
Yeah. Is it okay if I use that or?
Yeah. I would think so, yeah.
Okay.
Yeah, and from, it's a,
Yeah.
so you can,
Yeah.
you can go from there to Stampede.
Okay.
Rather than from your laptop.
Okay, perfect. So it's just your user ID.
ACC or oh no, I'm just no, I'm just select SSH. Just put up another password. Yes. Did you create it now? From here, you can just type in SSH. I thought you SSH space. Or do you your username? Okay, yeah, from here, you can just start to click on the spin to SSH and space. And then your username. Okay. So, you're tying your TACs forward again, all Texas, Stanky. And you're not going to
Well, I just wanted to
Okay.
yeah.
And you know this. When did
I created
When
like
you
a
get started,
go
you can set up your own business.
they're all strong in
Joe,
the
I-
the pipe.
Or I'm sorry, type in yes. And go ahead and type in your portal answers. Your type portal.
That's fine.
Go ahead and go to.
Do you want me to try logging in to the system here?
Yeah.
Yeah, I got so then I
I see.
go ahead and try this out.
See if this is the one I just put in.
It's very.
Yeah. Oh, you. So let me go. Look, make sure. Somebody looks like it's not. I'll be back.
I think you need to check your email. I think your account is named. You have to accept. Alright.
Yeah, I did.
Okay, yeah, you're still set as accepted. Still set as accepted. So, the email address that we have associated with your account is. Did you get something from that? So just smooth. This was on the 30, already accepted your account. So you check it email. I've got that part of the case doesn't matter a lot. Yes, absolutely. Okay. Okay, so you should have to change your username.
I know, if I can, yes, I can.
Yeah, that and then
Right, 'cause they had it there, so.
Okay, let's go. Let's go.
It's like I was accepted.
And have you already come through this other account? Those screen. Did you come here and set this up also? Okay. Well, let's try this.
Oh, really?
You got it.
Wow. It worked this time.
Yeah. Okay.
You guys can keep track. You guys
So anybody else having trouble logging in?
I don't either.
Okay, so that's 2 minutes. You log in the portal. Are you able to log in the portal? Okay, so let's go and grab your password.
So,
You didn't activate it for 9 people.
oh, I
It's
got
actually-
it for,
Okay,
Yeah.
it can take up 30 minutes for it to actually get pushed
Oh.
over the same.
okay,
So
so,
you're there.
yeah, I got it to work.
Okay.
If you just accepted it, might. Just wait. Make sure we're using password. There you go. Now, it's going to be a secure blog. You have 5 minutes for it to populate over you. Close that. No, yeah, right. Bring that to minutes. Creating an account. Excellent. Space. Yes. And then your username. Yeah. You have to specify those two, so it's your username and outside text. Yeah. So that's for see this. That's nice. The terminal guys, the mouse doesn't work in the terminal. What's that? The mouse doesn't work. No. And the cool thing about the terminal is it will remember if you want to use like the up down. Yeah. Anybody else having trouble? So you guys are on? You ready to rock? Yeah. Okay, open up the web browser. The last thing is Windows.
Yes, this guy. Oh, you are signed in here. Did you just change your password?
Did you put it right?
Mhm.
Just with the download of private workshop. Just that. So just go to the tab. Just follow that. It takes about 15 minutes for that information. Systems. Then you just accept it, right? The terms and conditions.
Right. There is. So you can read all this, the message of the day.
You're all set. Excellent.
Oh, you mean you're on? Excellent.
Use, yeah, DSP 4729.
Are you logged in? Okay. Just give it a minute, yeah. Not a problem. You just created the account, right? And you got the email as well. Process. On the website side. Just not sign out.
Yeah.
Jason, do you have the allocation up?
Yeah.
Who had J.K. Martin?
We can do 2 more minutes, we should have the initial thought. Okay. It's interesting.
And we almost have everybody logged in, right?
Yeah. I don't know if I did that. Especially now that we know we can do this. Okay, yeah. I've enjoyed what I've done so far.
17 Martin. No. Yeah, was it T Martin? JK. JK Martin. Added? Just a second. Okay. Yes. All right, only 2 more. So close. Yeah, I'm gonna try to change it. You can see the ones that takes about time. There first. Works there.
All right, we've almost got everybody logged in. Just a few more minutes.
Yes, I'm not 5 minutes. Yes. Yes. Just added. Oh.
You added J.K. Martin? Yes. Oh, you just added. Okay. What's that? No, it's fast now.
Yeah. All right. So, who do I not have?
I don't know. Oh, you got it there. Not including us.
Yeah.
That should be all of them then.
That should be it. Okay. They're all active too. Which is cool. Nobody's accepted and new or pending yet. I got 12 listed here, but at 13.
Oh,
They're in the back. Yeah.
yeah.
Let's try it one more time. 40, please.
40. Well, mine was 40.
Real close. There you go. I'm gonna go ahead and start and then you can give it.
No, for 1 semester. And then it's 9.
We'll go from there.
It's a secure.
For 1 year, it's 966, so 164. It's not, well, it's not a buffer, it's just like,
So you're just getting married.
There's a B.
4,000.
Yeah, so getting married.
It's 30,000.
Oh, yeah. Or 8. So how much is that? Yes. What are our policies?
Yeah, that's what I landed each year.
Oh, what is
Nope. Got 2.
Well, the only downside is my last one.
Oh, is yours,
That's what each one.
I think the problem is Washington is like, but in it's not necessarily.
Yeah.
Oh, okay.
Yeah. Yeah.
We got him in?
Yep.
Good.
Let's try one more time.
Yeah. That's probably the smallest person. Yeah, just like this. So you just want to teach all those. It's just kind of like. It's just like one view is like it's the world. Yeah. No.
Lady Bird Lady or sound like it's been here for a long time.
Few more minutes. Few more minutes. All right, I think we've got almost everybody on. Let's pick back up so we can kind of get through some of these hands-on pieces, and you're welcome to play along in the terminal, and we're going to make some files and move some stuff around and just kind of try to get you comfortable with the command line and playing around on there. So I think we got almost everybody on terminal. For those that don't, try again in just a few more minutes. See if you can get on and just kind of watch your neighbor there. So we've opened the shell, and now we have some of the basics here again on the common shells that are used out there. So we have sh, or shell, the original Unix shell. I wrote, it's still located in bin sh, but that's not really true. It's actually located in bin bash, which is the born-again shell, the second one here. It was rewritten for the GNU project and is pretty much the de facto standard on all Linux installations. So when we say sh is still in there, it's really just bash running in shell mode, running in old school mode. Two other shells that are pretty popular still out there in the wild, CSH for C shell, and that was intended to be modeled after the C programming language. If you write C and you look at C shell, you'd probably think that's not true. I don't either. So they did come up with TCSH, which is the old C shell with some modern improvements. Some of the things that they really liked from people that started doing in Bash, like, oh, look, I can do auto name completion and all these nifty little features. So they just kind of went back and added some of those features in there. Like I said, Bash is kind of the de facto standard on most systems. So what we're going to do today is we're going to take a look at some of these things, and we're going to talk primarily about Bash. So if you're interested in seeing what shell you're actually running right now, you can just type, let me close this. You can type echo $shell, and SHELL is all in caps, and what that is that's actually an environment variable, and we'll talk more about that as we go along. I seem to have closed my terminal, so I'm going to open one back up again. And for those of you that are on a Mac or a Unix system, you see when I open a terminal, I have a terminal right here, but if I want to get over to Stampede, I just type SSH, my username at the machine, so we want to go to Stampede. It'll ask me for my password. And the first thing you see when you log into Stampede is what's called the MOTD, or the message of the day. Make this a little bit smaller again. There we go. And there is some good information in here, and a lot of people tend to just kind of let it fly by and don't really pay attention. But basically, it gives you a little, hey, welcome to Stampede Supercomputer. It's hosted here at the Texas Advanced Computing Center in the University of Texas at Austin. Gives you a little, hey, here's some usage policies. These are, what you're allowed to do, things you shouldn't do. It's good to read through the usage policy just to make sure you're not doing something you shouldn't. It does give you a little point that if you have questions or problems, for you guys, you're all TAC folks, so you can go to the portal, .tac.utexas.edu, which I know a lot of you have already because you're setting up your accounts, and you can ask questions there. We also have a nice set of documentation. So if you go to our website and go to the user guide, you'll see a Stampede user guide, which covers a lot of information. And then we also have user news, because things do happen. It's a big machine. There's a lot of people on it. Occasionally, we take maintenance, typically once or twice a month on Tuesdays, meaning that we take the machine down so nobody can access it as we start to maybe update software, install new packages, things like that. And then you get a little more information of, hey, this is some important system notes. As the machine changes often, we install new compilers. There's new ways to do things. It gives you a little information, how to run an interactive shell, how to take a look at the queues, and we're going to take a look at all this kind of stuff this afternoon. And then this last little bit is really cool, because it gives you information about your project balances. So as you can see, I'm on a lot of different projects here. These are the names of them. These are the number of SUs, or service units, that you're allowed. So that's how we do a fair share on the machine. Is every project is allotted some number of service units. These are represented as the number of core hours, the CPU hours that you use. And then the last little bit that's pretty nice is your disk quotas, and this is one you do want to pay attention to, where it shows you we do have quotas set up on home and work. And it shows you how much you're using and what the limit is. It gives you a little percentage used, so you can quickly see, oh man, I'm way over my quota. I need to move some data or delete some stuff. And if you have a full home disk, you're at quota, you won't be able to run jobs. So that's a quick indicator of, hey, maybe something's wrong. I can take a look at this. And something we just added very recently is these TAC tips. So every time you log in, you'll get a little tip. We call it training through osmosis. Just short, simple, easy things to do. And so, hey, you can switch back to the last directory by executing cd minus. Hey, that's pretty cool. And you'll see all these every time you log in. You'll get a quick little informative tip. So what we wanted to do was, let's bring this back up. We wanted to see what shell we were running. You have a question?
Yeah, I was wondering about the service units. How do they work? Like, there have been times where I'm like limited on service units, and so it only lets me run 2 jobs. But other times, like, I don't know. How do service units work? Is it like just straight up core hours?
Yeah, the service units are just core hours. So if you don't have enough service units to run your job, the job verification script will make sure that it'll say, hey, you don't have enough SUs to run this job. So if we want to see what shell we're running here, we can just echo out. We can use the echo command. So I'm going to use one probably a lot here, the clear command, C-L-E-A-R, and that, of course, just clears the screen. So I have a nice clean prompt here. Is that big enough that everybody can read? Cool. So if I want to see what shell I'm running right now, I can say echo as a command, and I'm going to use this environment variable called shell. So echo $shell, and it says, hey, you're running bin bash, which is good, because I want to be running bash, and everybody that logged in right now should also have the same output on Stampede. You can also echo $0, which shows the shell that your account is using right now, because one thing I can do is maybe I say, oh, I really want to do something in C shell. I can just type CSH, and now I'm in a C shell session, and if I echo out $shell, it still says bin bash, right? Because what this environment variable is looking at is my actual account and not what I'm running. So if I want to see what I'm actually running, I can say $0, and it shows me, okay, cool, I'm running C shell. And to get out of C shell, I can just type exit, and now I'm back in my bash session. So you can change a lot of different modes here, and if you get lost or you get caught, you can always type exit and get back to where you began. One thing you can do on your own machines, but not necessarily on Stampede, is this command called change shell, or CHSH. So if you want to change your default shell, so you're running Ubuntu on your machine, and it says, oh, I'm running C shell, and I want to run bash, you can use the CHSH command, and that will allow you to change your shell for your account permanently. So, like I said, we're gonna play around with some of these. So I put these in the slides, and we'll give you a copy of them as well, so you can take a look at these afterward. But again, I already did the echo out $shell to show me what my default is. I opened a different shell. In this example, I used SH instead of CSH. So I said, hey, what shell am I using now? And I can look at the $0 environment variable to tell me what that is. And then I can also see what shells we have available using that change shell command. If I type change shell -L, it tells me I can't change shells on this machine. See, if I open one on my own machine, this is a Mac, and it doesn't like that. Don't want to close this one. So let's go here. I'm back here on Stampede again. And so I've shown you a few commands, right? We did echo. We looked at change shell. Before we go any further, there's something that everybody should know about, because there is a wealth of information stored inside the machine, and it's called man pages, short for manual. So before you go any further, when you're thinking about a command and going, gee, what are the options for that? I don't remember how to use it. Check out the manual first. And the basic way you do that is you say man and then the command right there on the command line. So for instance, we were just running echo. I can say man echo, and what this does is it brings up the manual that's stored on the machine. So I don't even have to go to Google to find out what's going on. I can do everything right in here. And basically, the man pages show you a basic synopsis of what this command does. It says, hey, this is the command called echo. It's made to display lines of text. And then it gives you a description which shows all of the different options that you can do. So For Echo, maybe not super interesting, but there is. But we do have a manual for basically every command that is built in. The idea with Linux and Unix was to make lots of small programs that do one thing very well. Echo, it does one thing. It prints out lines of text. LS, it lists the directory. So, and all of them, of course, have associated manuals with them. One thing that is kind of interesting too, if you're not really even sure what the command is that you're looking for, but you have kind of an idea, like, oh, I know I want to list, but I don't remember what the command is. You can use man-k, and then search for a keyword like list, and you see it'll give you lots of different commands, probably more than I really needed, but it'll give you an idea of here's ls right there, list directory contents. It'll show you a handful of what other commands might have that in their manual.
How do you X out?
Oh yes. So I did man on Echo, right? And I was looking at it, and I can use the arrow keys to go up and down and scroll through it. And then when I escape that, you just hit the letter Q for quit. Come again? Yeah, man, and then the command. So say I want to check out the man page for Echo. I just type man and then the command name, and then here I am in the manual page. Okay, and arrow keys will help you scroll up and down, and then Q, the letter Q, to quit. That was a keyword search, so I did man-k, and then I can search for specific phrases inside of the manuals. Is there another question down here? No? Question? You all set? Okay, cool. Did you get logged in? Yes. All right. So as I said, most commands have this built-in manual. Even the man command has a manual, so you can literally look at the manual for the manual. And this tells you exactly how it works. So hey, I can display the online manual pages, and again, these are all of the internal commands. And there's different sections of the manuals that'll help you out too. If you're looking for specifically system calls or C library functions, you can find a lot of this information in there. There are commands that don't have a man page associated with them, and you can find help with those usually by throwing the -h flag or -- help, or occasionally you'll even see some that are /question at the end to say, hey, how exactly do I use this? For instance, I think I can do this. I sure can. So I was taking a look at the ls command, and I said, well, what are the options that I can do with that? And I can just say -- help, and that'll dump out pretty much the man page is what it's giving to me. Some commands don't have a full man page, so you'll just see a small set that says, hey, these are the options that you use, or this is how you run it, something like that. So I think we all just had our lesson in accounts. Of course, to access any Linux system, you'd need to have an account on that machine. The account contains quite a bit of information about you. It has a username and a password. It has also what's associated with that is a user ID and a group ID, and these are numerical representations so that the machine doesn't have to think about, oh, I don't know what this name really is. It just associates a number to it. It also includes your home directory. It's a place to keep all your snazzy files, whatever you want to store in there. On our machines, that home directory is backed up nightly. So in the event that you did delete something, but you knew that it was there yesterday, you can submit a ticket and say, hey, I accidentally deleted these files. Can you please restore them for me? And we can do that. I say maybe quoted. It absolutely is quoted, as we saw on when I logged into Stampede. We run this TAC info script, and it shows me here's my quota on. Let me bring that up a little higher. Here's my quota for the home directory, and its limit is currently 5 gigabytes. So it's a pretty good amount of space to store stuff. And ideally, you really only want to store like your source code, something that you know that's important. What else? Your account also contains your default shell preference. So again, by default on our machines, it's Bash. You could change that to. You could make a request to change that if you, for some reason, wanted to use C shell. But that's a part of your account as well. So when we start talking about the shells, you have kind of custom shell preferences as well. So you can make your script, you can make these startup scripts do things for you when you log in. Maybe you want it to print another message, you know, hey, I'm on this machine, which is very helpful if you use lots of different computers. You can customize all of these with environment variables and aliases, all sorts of cool things. For Bash, you just use your .profile, and it's a full stop right here. And this nomenclature here is that you have a tilde and a slash. That means that's your home directory. So you can check it out. Yes? Yes? All right, so let's say I wanted to customize my startup script a little bit. Maybe I wanted to change the way that my prompt looks. This is something that I can easily do right in here. We can use things like environment variables, like I said, so I can export. Maybe I want a variable that goes to some really long directory that I never remember what it all is because it was in my work and project and research number 1 and some specific directory related to the thing that I'm doing all the time, and I never remember what that whole directory is. So I could just make an environment variable and say something like export my dir equals and then the path to that area. You can also put things in your path. Your path is $path is the environment variable that Linux is always looking at when you type a command. So if I type ls, it goes and looks through my path and says, where is this program called ls? And if I take a look at my path, I'm going to echo out that variable, you'll see that I have a lot of directories in my path right now. And the important one is probably user bin right here. If I'm interested in where it's finding some of these commands, I can type the command which and give it a program. So I say which ls, and it says, well, actually I'm running bin ls, so it's not in user bin, it's just in /bin, and it's aliased so that every time I type ls, it turns on the colors for me, which makes things look nice. See how I have things that are red and things that are blue. These are quick visual indicators to tell me what these are. These blue ones are directories or folders. These darker green ones are executable, and the lighter ones are just read. And we'll talk about some of those permissions and things as well. And then, of course, these red ones are, hey, these are tarballs or compressed tarballs. So let's say I wanted to customize my command prompt a little bit. So right now, my command prompt just says login to. Right, and that's not very interesting. Maybe I want to have something a little cooler, right? So what we can do is we can export PS1. PS1 is another environment variable that says this is what my prompt is going to look like. And remember what we're doing here. We're going to make it my username at some host, and then I believe this is going to print my directory and then a $sign. So we'll say /u at /h and make sure those are all lowercase. Yes.
There's a way we can get confidential show.
Absolutely. Yeah. I'll send them out to you guys after today. So what I'm doing is I'm saying again I want to change my prompt so that it says username at some host and then end it with a $sign. And there we go. The W is what directory am I in right now. So now my prompt is my username, J. Lockman. I'm at login 2, which is fine. And then it shows me the directory I'm in, which is currently my home directory. If I say maybe you went to work and something like this, it tells me this is the current directory that you're in, which is kind of nice. You can even expand that to show the entire directory that you're in. As you can see from the top of my screen here is how I have it set up, is that it's my username at the full machine name and then the full directory that I'm in. So you can do lots of really neat things with that, just a little customization. And of course you can do that in C Shell as well by setting the prompt environment variable. But again, we'll focus mostly on Bash. So in addition to accounts, as we talked about, everybody has an account on the machine, there's also this notion of groups. And groups are pretty neat because it can allow you to share things between each other, can give common permissions so that everybody can see something. So we always have groups of users. We have all users, and then we have maybe individual research groups, and they can share files between themselves. Each account is assigned a primary group. So if you were to do a Linux install on your machine, your group would probably be your username. On these machines, we can see that my group is, if I do a list on some of these files, we can see that here's my username, that's me, and this is my group, which is the default group that's added to every file I create. In Linux speak, again, everything's shortened. It's a GID or a group ID, and you all have one primary group, and then you can belong to lots of other groups as well. But you, of course, only have one primary group, which is the one that you own. When we're playing around with files, I think everybody kind of has this concept down already. We all know what files are. They're just basic units of storage, typically on a spinning disk. And every file must have a name. Simple enough. In Unix and Linux, file names can contain any characters, so you're not restricted to, oh, it can only be A through Z, cap and lower cap, you know, that kind of stuff. They can be really hard, although making them with strange and special characters can make them very difficult to access on the command line.
Or C.
Or C, exactly. So some of the things I always try to tell people is, you know, Windows has trained you to use spaces in your file names. Don't do that. It's very hard to access them on the command line because you have to escape every space. You know, it doesn't make a whole lot of sense to the command line. Try to stay away from too many special characters because some of them may be difficult to type. Unix file names can be long. How long depends on your specific flavor. Probably longer than anybody really ever cares to make them is the number now. And you know, another thing about files is they don't necessarily need a file extension, right? You usually see things are called something.exe or something.txt or .doc. Really, the only thing that does in Linux is tell a program that, hey, this is a PDF and you should open it with the PDF viewer. It doesn't really matter to Linux if you make it with a file extension or not. I make a text file and just call it foo. That's completely fine as long as I know how to open it and read it. All of those files can hold some raw data. It could be just text. It could be a binary. It could be a program that you wrote. And like I said, Linux doesn't impose any structure on files. It doesn't really care. If you want to make a file one way, then you're welcome to do so. But again, it's up to the application or the user to interpret those files correctly. If I try to open a PDF or a JPEG in my text editor, it's not going to look correct, right? I'm not going to see the picture because it's just a text editor. So I need to open it with the proper programs. Like I said, many programs, they'll interpret the contents of having some special structure. So think of a PDF, think of a Word doc, an Excel spreadsheet, something like that. These all have a special structure, and you would just use the proper program to open it. In scientific computing, we often use binary files for storage because it's a lot more efficient. If I have a file that's all text and I go to read it into my program, the computer has to translate each individual character to a binary format that it understands, even if I'm just writing numbers, right? I put the number 10, these are actually ASCII characters, and it has to go and look up each character and say, okay, I'm going to translate that to binary, and then I can start to work on it. So we tend to use binary format because it skips that step, and it tends to be more efficient in terms of storage space. So you'll learn about things this week like Fortran unformatted files. We'll talk about that later this week. And there's a lot of different scientific data formats out there. NetCDF and HDF are two of the more popular ones out there. There's also Silo. And they have their own special APIs and formats that they use for reading and writing, but what's really nice about them is that they're portable between machines. So if I write a NetCDF file here, I can take it over to my friends in Louisiana and say, here, just open it up with NetCDF, and they'll be able to read the data also. So it's not restricted to the type of machine I wrote it on. A little more on file names. Like I said, every file must have a name. That seems pretty obvious. You have to name it something. Every file in the same directory must have a unique name as well. So I can't have 6 files named foo in one directory. I could have 6 directories, each containing a file called foo, but they would all have to be different as well. And one thing to note that is very important, Linux is case sensitive. So it does matter if you type lowercase versus uppercase, and these would actually be 2 different files. If I called one Texas Fight all lowercase, and then one called Texas Fight with a capital T and a capital F, it will create 2 different files for me and not overwrite the first. Caveat though, Mac OS is not case sensitive. For some reason, they decided that that was a bad idea and stripped that out. So if you do this example on your Mac, you'll find that when I make a file called Texas Fight, and then I try to make another one with a capital T and a capital F, it'll overwrite that existing file. All right, so we've talked enough about files. Let's try and do something now. We're going to use a command called touch, and touch is just a very basic command that allows you to create an empty file. The syntax of how we do this is just touch and then a file name. So, for instance, let's make a file called foo, because we are going to talk about programming a lot. We'll probably see a lot of foo, bar, and baz. Let's go ahead and do that. Again, I'm going to use the clear command to clear my screen, get me right up here, and I'm going to use another command that I'll talk about later called pwd, and this command tells me where I am currently on the machine. I'll make this text a little bit bigger. So here I am in my home directory. I'm going to touch a file called foo, so I just say touch foo, and now if I do a long listing here, I do ls of foo, I see I have a file now. I can add some options to ls, like maybe I want to see a little more information about it. Let me clear that out so you can see it. So I did this, I added an option to ls -l, which says to do a long listing. And now what it shows me is a lot more information about this file. It shows me when it was created just a few minutes ago, or just a minute ago. It shows me the exact date. It tells me how big it is, and currently this is a 0-byte file because there's nothing in it, right? We just touched it. It also tells me the group that this file was created under, the owner of it, which is me, and then this information here is the permissions, and I have some slides about that for later on. So more info, check out the man page, and it'll tell you all about touch and how you can use it, and how you can maybe create lots of files at once. So we just made a basic file there called foo. No big deal. It's empty. It's just hanging out. We haven't done anything with it. But we'll probably want to store stuff in a directory so that we keep things organized. So directory is just a special kind of file. It's a container. You use it to hold information about other files. You can have tons of directories inside of your directories as well. And you may think of it as a folder that you've seen in Mac or Windows. Same idea. So what is a working directory? Well, that's the directory that my shell is currently associated with. So anytime that I'm logged in, I'm associated with some directory. Immediately when I log in, I can type pwd, and it shows me, hey, this is where you are right now. I'm in my home directory, and you see we have a special group set up because we have a very large parallel file system. If you're just on your Ubuntu machine or your Fedora laptop or something, you'll see that it's probably just called home in your username. But on here we have a little extra piece, so it's home1 00944 J Lockman, and everybody's is a little different. They basically put a couple of people in with each ID here, and again pwd, just showing me where I'm at. So if I get lost, I always know where I am. We've seen ls already a couple of times, but just to get it in there, it allows you to view files in the working directory. You can also pass lots of different options to ls so that you can look at what's in other directories, or maybe you want more information. I showed you the -l option so I can get a little bit more information about the files. And there's a lot more options that you can do if you take a look at the man page. So you can try a couple of these yourself. pwd, of course, is just going to show me where I'm at. So I type that pwd, and it says I'm in my home directory. We can see what's in this directory right now if I just type ls, and I see in my home directory on Stampede, I got quite a bit of stuff in here. Some of these files are from the class I taught last semester. Some of these are just kind of playing around. Hey, I have some debug stuff, some things doing parallel I/O, and a couple of training folders. So those are all the things in my home directory. If we want to look at the exhaustive list of options for ls, we can, of course, bring up the man page. If I just type man ls, and you get the basic synopsis here. Hey, it lists directory contents. It's a very basic program. However, it does have many, many options. So say I want to look at those dot files. Remember we were talking about the dot profile for your shell startup scripts. When you make a file with a period at the beginning, it kind of treats it as like a hidden file. So when I just type ls, I don't see them. But if I type ls -a, we see there's actually a lot more files that are hiding in my directory there. So it's a nice way to kind of keep it clean. Also, a lot of your startup stuff and things that other programs use will put dot files in your home directory as well. Yeah, one last note. Again, we talked about it. When you bring up the man page, if you want to get out of it, you just type the letter Q, and that'll quit for you. So let's make a new directory in our home directory called example. So we're going to use the makedir command, mkdir, and I'm going to make a directory called example. And all you do is hit enter. So I put in the command, called it example, and now if I want to see what's in there, I can say, why don't you take a look at what's in example? And no, I don't type that fast. I just used autocomplete, which is just using the tab key. So I said ls, I typed ex, and I don't think that there's anything else in my directory that starts with ex. So I just hit the tab key, and boom, autocomplete. Again, programmers are lazy. We don't like to type. So we can see that there's currently nothing in that directory, right? But we did create a file, right? We made that file called foo. We could probably move that in there. Let's take a look at what this file system really looks like first. You can think of the Linux file system as an upside-down tree. We say that because at the top, the slash, that's called root, or the base of the tree. So we think of it as upside-down tree, and you have lots of different folders in here for organization. We saw that ls was in the bin directory, right? So it's just in /bin. You have other directories too, like etc., users, temp, USR, all different things for different purposes, of course, and different flavors of Linux will put things in different places. But just to get the kind of idea, so maybe I have like a slash in users, or in our case we have slash in home. I have my home directory over here where I keep some programs in my Linux presentation. I have Scully with X files, of course, and then lots of other programs that you might use. So when you're navigating through the file system, just always kind of put this picture in your head of, you know, I'm climbing down the tree as I traverse through the file system. That's not what I wanted to do. There we go. It happens. Sometimes people get lost. You start tooling around on the system and you don't know where you are. But there's 3 very easy ways to always find your home. The easiest way is, of course, with just the command cd. That's just change directory. And what that'll do is just, if you give it no options, it'll just put you back in your home directory. If you like extra things, and I've shown you these so we can use stuff later on, if I use the tilde my username, that actually auto-expands to my home directory. This is also useful if, say, you're sharing files with a friend because you're collaborating on a project, and you say, hey, I put this file called foo.dat in my home directory, just go grab it. Well, and I log on to Stampede, and I go, well, I don't know where your home directory is. I know your username, but you have this weird number before it, right? So you can use this. You can use this to say tilde username and files, which is pretty neat. Third way is to do use the environment variable $home, and of course we could echo that out. What is $home? And that's set for me every time I log in. It shows me where that is. So again, I can cd, puts me in my home directory. I can cd tilde my username, still in my home directory. I can cd to the environment variable, and still in my home directory. So pretty cool. Just a couple of ways to get around, just to keep your sanity. And remember, that's an environment variable, the $home, and we can use lots of those as we go along. And we'll talk quite a bit about it tomorrow when we do shell scripting. One thing to think about as you're using some of these commands and you're creating folders and files and things like that, you need to have a concept of when we talk about relative versus absolute path. So commands typically expect you to give an entire path to the file. Now, we have some cool things like that path environment variable, where I say ls and it just looks in path and goes, oh, I found ls in the bin directory. So we call those relative paths. If I just say, hey, go find it for me, or I'm in my directory, just run this program. So I can do things like, let's say I changed directory into that example. So now I see I'm in there. I can do some interesting things, like I can say, let's just go up relative to where I am. So here I am in this directory. I can say cd ... And that just says go up one directory. So I do that, and we see that now I'm just in my home directory. We call that a relative path. If I have a file here, like I have this file called foo, maybe this was an executable, I could say /foo and run this program. And what it's saying is, again, relative to where I'm at, run this program. Now, the other thing you have is absolute paths. These are full paths. So you're telling the shell exactly where this file or this program is located. Basically, the easiest way to identify that is there's probably a slash at the beginning. So it's saying start all the way at the root, go down into these directories and run this thing. So for instance, I could say /bin ls, and I just get the regular old ls command. Remember when I typed ls without anything, I get colors and everything. And why is that? Because when I type which ls, it tells me what it is. I have ls as aliased to use ls --= color equals auto. So kind of neat. And again, full paths if you need to. Most of the time you can do relative paths when you're just kind of traversing around and moving things. So let's highlight a couple of other commands, and then we'll do a few more hands-on parts. CD is changed to a directory. So from wherever you are, you can go to some new path, and this you can use relative or absolute paths as well. So say I'm here in my home directory, I could just say CD example. Relative path says, okay, start from where you are and look forward. Let's go back to my home directory by just typing CD. I could say, well, I want to go to that example directory, but I'm going to be explicit about how I do it. I'm going to go to home1 00944 jlockman example, and it does the same thing for me, right? LS, we've seen quite a few times, and you're going to continue to see it. You're going to use it a lot. It has a lot of options. Again, I showed you another little, use the -A if you want to see those hidden files or files that start with a full stop. Move, the MV, just can move one file to another. You can also move a file into directories with this command. So maybe I just want to rename the file. I called it foo, but I meant to call it bar. I can just say move file bar. So let's do that. Let's first move this file. Here I have this file called foo. Let's move foo into example. So I just type mv foo and then the directory that I want it to go into. And now if I take a look for foo, I see that I don't have anything, nothing in there. So if I go into my example directory, we see I now have this file called foo. Great, I moved it around, nothing too crazy. What if I wanted to rename it? I didn't like that it was called foo, I wanted to call it bar. I could say move foo to bar, and again, this is not a directory or anything, it's just saying, hey, change the name of this. And there we go. Now there's only a file called bar. I'm going to move it back just to keep it, yeah. Move bar to foo. There we go. What else do we have? Copy, CP. You'll notice all these commands are very short as possible. So copy, very simply just copies files or directories. So I can make copies of files that I have and make new copies, call them something different. I can make copies into different directories, all that kind of stuff. RM is to remove a file and directory. I put the most dangerous command you can run in here just because, you know, I like to live dangerously. So rm-rf is to recursively move everything without warnings. So it's not going to tell you anything. It's just going to go, sure, I'm just going to delete everything you see here. And then if you use the asterisk, that is a wildcard character. You say rm star, it's going to delete everything it sees. Question?
What's the difference between R and RF?
The difference between R and RF. So F is force, meaning that I don't want to see any warnings or anything from the machine. And R stands for recursive, meaning that go through all of the directories that you see. And we'll talk more about.
If you say RM minus R and you got a directory, it's going to stop the directory and say this directory is not empty. If you really want to do that.
Okay.
Right.
Minus F is just going to traverse everything.
Yeah, it's just going to forcefully do it. And we'll do some commands to play around with this. One thing I like to do before I do an RM is I tend to use ls to see what files it's going to delete first, right? So especially if I'm using wildcards. So maybe I say, let's do a copy here, foo2bar. Now I have 2 files. So if I was going to try to remove all these, I could say rm star, and it would just delete all the files. But what if I said, well, maybe just remove everything that starts with an F? You know, something like this. This is something I could use ls for, F star, and it would show me just those files that are going to be deleted when I run the rm command. Yes?
So we use a wildcard character at the beginning and then...
Sure. Yep, you can use that wildcard anywhere. We'll talk a lot more about that too when I get to the end of this talk. There's another neat command called rename, which allows you to rename from file names. For instance, maybe you wrote a program that writes out, you know, step 1, step 2, all the way through step 100. But unfortunately, because you did that, you didn't have any zeros padding that name. Now they're all out of order, right? The first file is step 1. The second file is step 11. The third file is step, right? As we go along. So you may use the rename command to do basically you can wildcard in there and say, hey, I want extra zeros in front of that, or I just want to rename a ton of files at once. Very cool program. So we can do a couple of these right now if you want to try out some of these commands. So I already changed into the example directory. Let me clear this out. So I'll start from my home directory by just typing cd. So again, now I'm back in my regular old home directory, and I'm going to change into that example folder. And so now here I am. We can take a look at what's in here. Yes. The autocomplete tab. Yep. Start typing and then hit tab. So you can take a look at it. Here I'm going to add a couple more options to ls. I'm going to add the L, T, and R, and we see what happens there. Now I get a L is for the long listing, T is for sorted by time, and the R is reverse that sort. So show me the newest on the bottom, which I tend to do, especially if I'm in a big directory like say $home where I have a lot of files. I just kind of want my most recent stuff right here so that I can see it. I don't have to scroll back up and then go, oh, there's the files. So you can do that. You can change back into your home directory by just typing cd ... I mean, that's a relative path to just say go up one. You could also just type cd with no options, will put you in your home directory as well. And then let's move that file into the, if you haven't already, move that file, let's go back to my home directory, and move that file, foo, into example, like that by typing mv space foo space example. And of course I already did that, so if I change back into example and do an ls, I see that I have this file called foo. We've already done the long listing, but again, you can take these home with you and you can play along with them. If you forget some of them, we'll have them here for you. We already saw how to create the empty file, so I could just do touch and make a file called bar. I could also copy that file and make it a new name, so I have 2 versions of it. So let's say I'm in here and I got this file called bar. I could just say copy bar, and let's give it a new name, Faz. So now I have 3 files in here. Of course, if I do a long listing here, we'll see they're all of 0 size because, again, we just did a touch. There's nothing in them yet. So now I have that directory. Let's go ahead and remove that file that I created called bar. And in this case, I'll use an absolute path because I'm going to give it the full path by using the $home environment variable. So I'm back in my home directory, and I'm going to say rm $home example bar. And you see I use the tab autocomplete, and it just kind of expands it for me automatically. And I say, hey, I want to remove that file, and it says, okay. Just brings you right back to your prompt. Remember, it doesn't ask you, are you sure? It doesn't put it in a recycle bin. It's just gone. So you do want to be cautious when you're doing that stuff. There is one command that you can add to RM if you do want to be asked every time. It's the -i option. So let's say I wanted to remove, and I'll add -i. It stands for interactive remove. We'll say $home example and that other file called foo. So when I run this, it'll say, hey, do you want to remove this file? And you can say yes or no. I'll say no. So there is that option for those that want it. And one thing you could do, if you always want to be so cautious that you don't want to ever delete anything by accident, you could alias RM to RM-I, just as we have with LS. Let's say I wanted to remove that directory entirely. That's why I showed you the R and the F. So that's going to recursively delete everything in the file or everything in the directory. So if I just tried to remove example, it's going to give me a little warning. It's going to complain, right? So it says, let me clear that out so you can see it there. So I say, hey, remove example, this directory, and RM says, you know what? I can't do that because it's a directory. You have to tell me what to do with this. So we can say RM-RF example, and now it's gone. Everything's deleted, all the files underneath it as well. For your notes, I did put in the slide here about when we talk about recursive directories. I've talked about that a lot. We're not talking about recursion in terms of programming, but really just the manual will say it a lot of adding these recursive options to directories. And again, all that means is perform that action on a given directory and recursively to every file and subdirectory underneath it. So we'll use this when we use copy. If I want to copy a directory of files, we want to add that -r so that it gets all of the files inside of the directory as well. If I just say copy a directory, it says, okay, I made a copy of that directory name and it's empty. Kind of useless for us. So you always want to add that on when you're doing that. And the copy is just -r for recursively, and then the source, and then the destination. So maybe I had that example directory still, and I wanted to make one called example2. I could say cp-r example to example2. Do you guys want to take a break? 10 minutes? Okay. Let's do that. We'll break for 10 minutes, and we'll start right back up at 11:15. There's still tacos and probably coffee.
Can you actually tamper with whether or not Linux registers whatever command you put in with case sensitivity in mind? Like, can you turn off case sensitivity?
Well, that's what Mac OS did.
Right.
They turned it off.
So
you probably don't have that option.
Yeah. Okay.
They did a kernel patch for that.
Okay. So it's not too bad.
Yeah. No, and you really want case sensitivity. It makes more sense because then you can have
Right.
2 different directories all with the same name.
Right.
So maybe you have all in caps as your final project or something. Otherwise, your working project or something like that.
Yeah, for sure. I remember back when I had to use Sigwin, for whatever reason, it was not case sensitive, and it was very yeah. It's not a lot of fun.
So you dual boot this guy, or you just run Ubuntu all the time?
So I have 100 gigs Ubuntu on my hard drive is just Windows 7, I think.
Okay.
Honestly, I think I just want to get everything to Ubuntu because I hate Windows 7 now. So actually, that's the question I was going to have. How does Ubuntu compare to like that Debian, Red Hat, Slackware?
Ubuntu is a Debian.
Oh, it is.
It's a Debian branch. And essentially Debian by itself is not really going anywhere.
Okay.
So most of the development on that branch is through the Ubuntu group.
And I believe it's like Red Hat was pretty much the preferred.
Yeah, well, Red Hat is the it's hardened and server ready. Ubuntu is great for desktop or laptop, but you wouldn't want to use Ubuntu for say OS.
Okay. All right. Fair enough.
You have a Windows by chance? That's not even
Yeah, I'm running. I have a Mac, and I have a Linux install in VirtualBox, and I have a terminal server that runs Windows.
okay, because I tried to VirtualBox and that my PC, but then it wasn't working, so I was trying to make myself actually only use one of mine, but I wanted to use the actual.
I find that Mac OS only runs well on Mac hardware. Doesn't run well on a virtual machine. So it'll work the other way. If you have a Mac laptop and you want to run a virtual machine of Windows or a virtual machine of Linux, I think it's fine. But doing Mac OS in a virtual environment is better.
So, what would you recommend for like
Xcode, you can do it right in Linux. You don't need a Mac. Yes, absolutely. You were wanting to do mobile development? Yeah, you can do a lot of that in a Linux environment. Or if you're specifically only wanting to do iPhone, iPad apps, you should probably go with that. Yeah, I know, it sucks, but that's their model.
yeah, they make it so
Yep. Yeah, you can do some quite good development in some of the next two. Especially if you're targeting Android phones.
the problem is, this sounds really stupid, I don't have so it's like, well, I just started with my phone.
Right.
But then I have a Linux.
It is, yeah. Well, I mean, they finally got away from having to dock every time for doing the updates. It goes out over the air now. But, first gen iPads or iPhones were like, none of that. Buy an iPhone. There's other tools out there too that do cross-platform development. I don't know right off the top of my head, but I'll figure that out.
So what would you recommend? What I was thinking of was playing around with those like fake, like a wannabe Xcode that you can use in a lot of chat. But then the problem I was having, like, with this, I think it's called like Xcode Suite.
Yeah, I haven't used any of those, but yeah, I would recommend looking at if you want to find some development like that. Yeah, I know. It's not my favorite thing either. So you guys all just live in Austin today? And some of you guys are from here, right? Happy the semester's over? No summer classes? No summer classes? Oh, it's this or nothing?
Yeah.
Okay.
You are? Are you really? Wait, can we do that? Because I really.
It's the recommendation not to, it depends on how much work you
I would talk to your professor or whoever you're like, because ultimately, like, most of your work is going to be done.
Ask your mentor, but I just find that, yeah, it was fun.
I'm emailing her a lot.
Are you guys going down to meet with them this afternoon? You're like, you're here until like 4:30.
Wait, did you say that you have the same mentor?
Yeah.
Do you know?
I mean, I sent her an email.
And she never.
All I'm saying is,
Is her amazing?
yeah, she didn't respond, so I'm wondering if I actually did use the same email that, I should, with those of you who have an email for her. So that may have done off maybe.
I used the email I found on her. I used an email that I found on her, like, actual.
What, so it's like you,
YouTube.
yeah. Yes, I used another email, not the one that, was more than
Oh.
So,
I don't know if she didn't respond, and then I sent her number, and I was like, "Hey,
or something.
because I don't want to really reach out. I don't know what I'm doing. But I think I said
How's the pace so far? Too fast, too slow? I know I talk fast, I'm from the north. It is a crash course.
Yeah.
Yeah.
Seems like a lot of room.
There's a lot, but the thing is, you know, when I show you maybe 30 commands, you use those commands all the time. Yeah.
What do you mean by that?
This is a crash course. Yeah. We're going to give you a ton of information in 4 days.
Yeah.
Oh,
Actually, I didn't even know it was from 5. I looked at the thing and I was like, oh, it's going to be from 8 to like 12. Look at it, 8 to 5. Oh.
Yeah. No, I have it stopping at 4:30. And today we'll end a little early so that we can do a tour of Stampede so you can check it out. Because it's pretty impressive.
Can we come here whenever we want to work? Like, if we want to just come over here and do our work, is there a place that we can
I have to ask Rosie. I think so. We have a student area, but we're really cramped on space. That's true. Yeah, there's a lot. So if you're in the, you go to the Fawn Academic Center to get your ID. You go there. That's a big open space, and during the summertime, it's not that busy. It can get loud in there though. So there's other places too. The Union is typically pretty quiet.
Is there like a place in the library?
There's a bunch of libraries.
I have one library in my school.
I really like the tower, like, if I'm here, and I'll
Yeah.
Is there Wi-Fi at that usually? Or is it-
There is, yeah. So, they didn't give you Wi-Fi access? Or
Well, they gave us,
We gave you something. We gave you that.
but when they said on the dorm, it says you have to plug in. Oh, you can actually use the ID.
Yeah, you just log in with your EID and, restricted Wi-Fi.
Restricted ones, okay.
Yep. And yeah, you probably plug into, you have a machine.
Yeah.
I mean, sometimes.
Just be cautious. Don't download stuff. Because they'll turn you off.
But how did you feel?
They're quick about that.
They are?
Yeah.
My school's not.
No, and you have a limit too. So students have a limit of like a gig a month.
It's like a per week.
Oh, is it per week?
You can sell it.
There's some tickets.
So much Netflix.
Well, like, they have like different, I think it's like,
But don't take
they have different amounts. Like, you know, it's.
Yeah, and then there's a
you
pay
buy
model
extra,
too. Yeah.
and then you're. I always have to like, oh, gotta wait till Monday.
Right. Guess that file's gonna wait till later. So has everybody seen this Raspberry Pi? Have you seen this before? Yeah. Seen it online? They're pretty awesome. $35. Yeah. Well, it's actually a full computer. It has an HDMI. You plug it into a monitor. It's got 2 USBs, so you can plug in a keyboard and a mouse. It's got RJ45, so you can plug it into the network right off your switch. Or what I do is I bought a little Wi-Fi dongle and a USB hub. So I plug a hub into here, and then I plug in my keyboard, my mouse, and my Wi-Fi dongle. And then what else it has? Audio coming out right here. USB, audio. It has a set of I/O pins, so you can do cool. They call it GPIO interface, which is kind of cool. You can use it to control like LEDs or small motors or anything plus or minus 5 volts. So you can make lots of really cool like robots, things like that. And then, like I said, it has a SD slot on the bottom here, so you can store your operating system right on there. You can also use that as your working system. What I like to do is just put the bootloader on the SD slot and say boot off of a hard drive on my USB. So these are very slow in terms of read-write speed. So it's a little, and it's only a gigahertz processor, so it's not super fast, but it is workable as a full computer. So they're pretty neat. I'd say in reality, yeah, they're $35, but then you buy a case, and then you buy an SD card, and then you buy, all the other stuff. You're still talking under $50. You can get like $6 cases online. People are printing them with 3D printers. People are using these to control 3D printers. So we do a lot of really cool things with it. You can check it out. There are printers out there for purchase, about $1,500 entry fee. You can build a rep wrap, which is a bootstrapper that will build one piece that helps you build the 3D printer. And once you build that, you can build as many 3D printers as you want.
Undergraduate has one that's 350.
Really?
Called Simple, yeah. And I have.
Awesome. There's also the Maker Lab. What's that place called? The Tech Shop in Round Rock. And they have 3D printers. They have all sorts of cool machines. You can make stuff. And it's connected to a Home Depot or a Lowe's. Yeah. So you can just go and buy all your material and go back in there and spend all your money, spend all your time. It's a cool place, though. And yeah, those are really neat. I like those Raspberry Pis. We actually built a small display cluster off of them. Whenever you take the tour, it was just a demo to try it out, but when we take the tour, you'll see we have this network operations center where we have 24/7 coverage of people that are monitoring the machines and everything, and they have this big wall of monitors, and basically we put 6 Raspberry Pis on a pole. Like basically, we just use the mounting hole and put a thread through it, so there were all of them right there in a row, and just plugged them all in and made a massive display setup. It was pretty cool. Yeah. So you spend all the money on the monitors and nothing on the computers. All right, let's get back going so we can get you out for lunch at noon. So we talked a little bit about quota, just that you know that you have one. You can see how much space you're taking up by just typing du. That'll show you how much space a folder or directory uses. So you can say du, a file name, and it'll tell you how large it is. You don't always have to do that though, because you could also just say, let's say I have some files in here. If I just do an ls-l on, say, my lab 2 here, it tells me how big it is right here. And maybe you don't like reading things in bytes or kilobytes, right? Hey, that happens. Well, all of these commands deal with information in kilobytes or bytes. And unfortunately, nobody finds that useful anymore. Because we're talking gigabytes, petabytes of stuff. So they did add a new option, it's -h, and it does work for most of the commands. So you can say -lh, and we'll give it to you in a human-readable format. So let's say I said ls-lh here, and it'll tell me, hey, it's 50K, 50 kilobytes. A little bit nicer, right? Also, especially if you're doing, say I'm doing the df command, I'm on Stampede, and I'm like, wow, there's a lot of different file systems, and look at how big these numbers are. I don't even want to begin to start thinking about what that is. I can just say df -h, and then we can see very quickly how big these are. So we can see some of these other file systems like home is 524 terabytes. And as we saw before, that's a big number. So I use that -H quite a bit when I'm looking at files, just so that I have a more human readable representation. You can see work here, 19 petabytes. It's pretty awesome. And Scratch, 7.5 petabytes. And again, that's a big file system there. So use the -H. I use that a lot. Yes. DF displays the information of the entire system, so all of the mount points. So on our machines, on Stampede, we'll talk about this more this afternoon, but you have a home directory, a work directory, and a Scratch directory. Home, again, 5 gigabytes backed up. Work is a place, it's not backed up, but you do get quite a bit more space. You get about, I think you get 500 gigs on that one. That was really maybe that's just me. And then you also have Scratch. There's no quote on Scratch, but it is a very large parallel file system. So if you're going to be doing any sorts of really neat parallel I/O operations, or you're doing lots of data writing or reading, you want to use the Scratch file system, because the way parallel file systems work are the bigger they are, the faster they can be. All right, so we've talked lightly on permissions. I've shown you this little, hey, there's these things with the RW and the X, but now we can talk about it a little more in depth. Because Linux is a multi-user environment, we do need some way to keep permissions straight. So, so I know what my permissions are, what the group permissions are, and what the world permissions are, everybody else. The permissions of a file can contain these 3 things. You can be read with an R, W with a write, or X with a execute permissions, and of course they can be all 3 of these as well. They're arranged into 3 groups of characters. So the first set is the user or the owner. So typically, if you write a file, you're the owner of it, and those are the permissions that you've set for it. The second set of 3 is the group. So remember, I said we all have a primary group, but you can also be members of lots of other groups. So you may want to set the group permissions. I'll take that back. Thank you. And then the last set is the world, or others, everybody else on the machine. So you can set read permissions for anybody that can log into that machine. Well, in this case, I said the user, or me, has read and write. So I can edit this file and I can read it. And then I said, well, people in my group, they can read this file, but they can't write it. And then I said, well, everybody else can read it too, so that's fine. I could have said, I could have changed this to be nothing for the group, but basically I just wanted to show that basically I can say anybody in my group and everybody else can read the file. And if we take a look at some of the stuff in my home directory, you'll see it has lots of different permissions here. The D stands for directory, so they're kind of a quick thing there if you don't have colors turned on. And you'll see, like, for instance, this one right here is I have read, write, and execute. That's the user. I gave people in my group read and execute, and then I gave the world read and execute. That way, anybody can read it, anybody can run it if it was actually a program. But in this case, it's just a C program. To change the permissions, you change the mode or change mod as the program goes, and that'll allow you to change permissions on a file or directory. I urge you to go and read the man page about how to do this, because there's a lot of different ways to do it. Many people still are staying with the old school octal representation, which I tend to use, and I know that confuses everybody else. So go and read the Google page about how to change permissions using chmod, so that you can play around with that, make things readable by everybody else, make things executable, etc. You'll also need to make sure that you make things executable if you say write a shell script. And we're going to do that tomorrow when we talk about scripting. You'll just make a file with an executable permission so that you can actually run it. Other commands here: change group and change own. I just wanted to show you these. You typically won't be able to do change owner, because you can only change things that you own, and you can't change them to somebody else. Only root, who is the super administrator, is called root. He has permissions to change the ownership. He has permissions to change the groups. And of course, both of these support the -R option for recursion. So say I have a whole directory, I want to change the ownership of all of them. I can say change own -R this directory with some owner. Same thing with permissions. Let's see, what's everybody else up to on the machine? Well, there's a lot of things going on that you can take a look at. Oops, there we go. A lot of different things that you can take a look at to see what's going on. Top is a nice program that gives you a detailed description of all the running processes. I showed you that right at the beginning of the program, beginning of the talk. So if I type top, we see here's all these users on this machine, and they're of course all running all sorts of different stuff. Here's me running the top command. I popped out of there, but lots of other people running. We got people running the gzip program. We got people running rsync, which is a copying program. We got people running tar. They're making archives. So you can kind of see what's going on. And in top is really neat. If you hit the number 1, it'll also show you all of the CPUs individually with their load. And of course, on Stampede machines, we'll talk about this afternoon, you have 16 cores on there, numbered 0 through 15, and you can see kind of the load of the machine, what's going on. And top, just like the man pages, you just hit the letter Q for quit, and you're out of the program. Another one I use often is uptime. This shows how it shows the system load and how long it's been up, which is pretty useful if you're hopping around a machine and you say, oh, you know, I was on this machine like a week ago, I think, and my code worked, and maybe somebody rebooted it and something happened, which is why it's not working now. You can use uptime to say, hey, when's the last time this this machine was rebooted? This machine's been up for 9 days, 164 users right now. And then it shows you the load average, 5, 10, and 15 minutes. So you can see kind of course, 1 would be 100% load, but there's 16 cores, so they just add those numbers together. Yeah, sure. Cool. All right. This will happen. You'll write a piece of code that behaves badly. Something that maybe you put an infinite loop in. You said while 1, do this, and it's just going on forever and ever. Sometimes it's just a syntax error. You said, oh, I forgot to put in the thing to make it stop. So you'll probably run into this more than once in your lifetime, but there are plenty of ways to kill processes, basically by their process ID, which again is that unique identifier for the process that's running. A couple of things you can do. You can run ps-au, and that will that'll show you all of the processes that are running right now with their process IDs. You could look at top, and you could say, oh, there I am. There's my process ID, and kill that process ID. If you're just in the way to do that is you use the kill command, K-I-L-L, and then the process ID, and that will kill the program. You can, of course, only kill processes that you own. You can't kill everybody else's processes because that wouldn't be playing nice. But root, of course, can. You can go in there and just kill everybody and say, we're all done, we're going to reboot the machine or something like that. If you're running a program, say you're running like a C program and you put in an infinite loop and it's just sitting there at the prompt and it's not returning, you can just hit Control-C. That will typically kill a session. Or kill a running program, and if nothing works, you can try Control-D, and that will typically kill the entire session. So you're logged into Stampede, you hit Control-D, it should kick you out. There's lots of other advanced program options, of course. Often I want to run commands in the background because I don't want to wait for them to return. Maybe I'm running a program that sorts through all of my input files and does something, but it takes like 5 minutes, and I don't want to sit there and wait at a prompt. I want to do other stuff while that's happening. You can just throw an ampersand at the end of your command, and it will put it off in the background. And then when it completes, you'll get a message on your terminal that says, "Hey, process terminated, process complete." That's pretty nice. And then you'll probably also want to use the asterisk or the wildcard because you'll use that quite a bit. You say, "Hey, I want to copy everything into some directory." Or I want to delete all of these files, or everything that starts with an F, or everything that starts with an O, or something like that. of course, this option can get you into trouble if misused. So remember, I put the most dangerous command you can do with rm star. Be cautious with wildcarding. A little more on the backgrounding. Say I'm running this little script that goes through all my files, and it does take like 5 minutes, but I forgot to put the ampersand on. Now I'm sitting there and I'm like, oh, I really just want to do something else while this is happening. You can background a job by first suspending it. So say it's running and you're waiting, you can hit Control-Z, and that will suspend the job, put it into a queue, and then if you just type the command BG, it'll put it in the background and do it just like it would have if you had put an ampersand at the end of the command. If you want to see what's going on with that job, hey, it's been running for like 5 or 10 minutes and I haven't seen any reply back, you can type FG and it'll bring your job back to the foreground so you can see what's going on. Yes?
Can you run a job in the background if you log off of your session?
Yes.
Okay.
It will complain though. It'll say, hey, you still have jobs running. Editing and reading files. This one's fun. Did everybody use an editor already? Some? Yeah. So there's two. Well, there's more, but there's two main editors. There's Emacs and there's VI, or now known as Vim, which is VI improved. It is amongst the largest nerd battle in history. If you're interested or care to see, you can go check out the editor war on Wikipedia. You can see awesome things like Richard Stallman's Church of Emacs for all of the Emacs lovers and all of the VI people who say, well, you have to do too many key commands to do anything. The point is, they're both very good, simple text editors, and people tend to choose one or the other. When you do one, it makes it very hard to learn the other, I think. It's kind of the mode. Kind of like if you play racquetball, you shouldn't play tennis, because it just doesn't work. So Emacs relies heavily on key chords, so multiple keystrokes, Command, Alt, F, Enter, Insert kind of stuff. Whereas in VI or Vim, you tend to enter and exit the editor repeatedly. So I'm a VI editor, VI user myself, and that is exactly how we use it. You open it up, you go into insert mode, you type some stuff, you escape out of insert mode, and then do programmatic stuff like copy lines, paste things, move stuff around. So we tend to enter and exit a lot, and then use the shell itself for more complex tasks like move these into directories and stuff. In Emacs, you can kind of do everything in one mega window. There's another one out there, Less, which is a very simple program if you just want to read a file. So maybe I don't want to open it and edit it, I just want to see what's in there. There's two commands. I'll show you Less first, but the thing is here, let's take a look at maybe this allocate program. The one thing I could do is I could just use the program cat, C-A-T, and that just dumps it to the screen. It says, hey, that's the contents of that file. There it is. I could also use a program called more. So more gives me a page by page. So I can see it, and it stops at the end of the terminal and says, hit spacebar, and you'll get the next page. That's pretty cool. But then somebody came along and said, more is just too basic. I want something cooler, so they made Less. And this is where the less is more comes in, because less technically is more. You use the less command, and now I can actually move up and down in the file. Ooh, fancy, right? You can also do a lot of the VI style command arguments. Say I want to look for something like calls. We can just do a / search. You can move around with the VI standard characters, H, J, K, and L, which is pretty nice. And then to get out of the less interface, you use that standard Q to quit and get out of there. Again, that's just 3 ways that you can look at a file's contents without editing it. And if you are interested, definitely go check out the editor war. It's pretty funny. Searching for files. You'll probably make a lot of files, and then you go come back the next day and go, I know I called this file foo, but I do not know where I put it. One thing you can do is you can use the find utility. which will search a directory for a file that you're looking for. In this case, I said, hey, find a file called foobar. And maybe we'll do this example. I say I made a file called foo or something. You say find dot, and what this dot says is, let's go back to absolute relative paths. This says find in my current location a file named, that's why the minus name, foobar. And what it'll do is it'll search all of the directories in the current working path, and then it'll spit out, if it finds it, hey, I found it in this directory called tester. There's your file. And then I went ahead and I said, well, let's use the cat command, which I just showed you, to show me what's in that file. So nice, simple utility. Again, goes back to the whole lots of small programs that do one thing and do them well. When we talk about input-output or I/O, we know that programs and commands can contain input and output, right? I can give a program a command, say ls this directory, and ls says, well, here's all the contents of that directory. And Linux programming is often, as we call, stream-based, meaning that we have 3 different streams that we can use. Standard in, or 0, is your standard input. Typically, you're typing in from the keyboard. Standard out is output to your screen, or long ago, output to a printer. And then you have standard error, which is just error output, and you can send that to the screen as well. You can also redirect any of these however you want. So when you're writing a program, you can say, hey, when I'm printing out regular stuff, just print it out to the screen, but print all the standard error stuff to a file, because I want to look at that later, and I don't want it interlaced. Oftentimes, I want to save the output from a command that I ran. So maybe I wanted to go back and look at, I did a ls of some long directory, and it had just too much on the screen. I want to put it all into a file so I can maybe look through it and find what I'm looking for. You can use the redirection operator just like this. You say run some program and dump the output to a file. So maybe I want to, so let's say I did an ls-l on this /etc directory, or etc. And it is pretty long. There's a lot of stuff in there, and I went, I don't want to scroll. I just want to put it into a file. I'll just say ls-l/etc. and redirect all the output to this file called my list. Now we see I didn't get anything on the screen. It just made a new file, and I can. What do you want me to use? Less, more, cat. Less. My list, and there we go. I can see all of this has been dumped out to a file for me. Pretty cool. In addition, say you wanted to keep adding stuff to that file, you can use the double chevron to continue to append to that file, so it'll keep adding stuff at the end. Let's see. The pipe operator is pretty neat because it allows you to link different programs together. So now I'm going to show you a little bit of interesting things. So maybe I did an ls-l of some directory structure, and I'm really only interested in how many files there were in that directory. I don't really care to see them, I just want to count them. So I'm going to use this command called word count, WC, again, short as possible. Word count, and I give it the option -l for just count the number of lines. And so you can use this on a program. Say you're just looking at a C program that you just wrote, and you went, man, that's like 1,000,000 lines of code. You could say, well, no, let me word count it -l, and it'll tell you exactly how many lines it really is. So let's say I wanted to do this. I did a ls-l on etc., and I said, oh, there's a lot there. Let's just count how many there are. We'll do ls-l, and I'll pipe it to word count -l. And it gives me a quick number. It says, hey, there's 284 things that I found when you did that ls. So pretty neat. Lots of other useful commands. Sometimes files are too big, or you just don't care to read the whole thing. You just want to see who wrote this file, or I just want to see the comments, or I just want to see the end of it. Maybe it's a long output file, and really the only thing you need is that last number that's output. You don't want to open a 1 GB file, ever. So you can use commands like head and tail to print the first 10 or 5 lines, however many you like. You have a question?
When you use a command on the top and you output it to a file with the chevron, does it just continue?
No, it just does a one stop, just a snapshot. So let's say I wanted to take a look at a file here. We can use the head command. Well, here, let's first word count how many lines are in this. I believe it's 49 here. If I do -L, we'll get our just the line number. So 49 lines in this code. And let's say I just want to look at the first 10. I can say head allocate, and it shows me just the first 10 lines of that. Which is a nice little snippet if you just want to see like the header, or a lot of times people will write in their code at the first 10 lines is this program was written by so and so with this license and whatnot. Or maybe I just want to look at the end. I can say tail of this program, and we just get the last 10. You can also change the default number. So maybe you want to see more. You want to see less than 10. I only want to see 5. I need head -N5, and now it's only going to print 5 lines out for me. So you can do a lot with that, just kind of taking a look at stuff. History is another cool one that prints out your command history. So all of the commands that I ran. I find myself, I'll be working late at night, and I did some cool one-liner command that gave me just the thing that I wanted, and I come back today and I go, I don't remember what that was. It took me a long time to come up with it. So you can type history, and this will show you a lot of the last few commands that you've run. So we see all of this that we did earlier, doing the PWD, making the files, and then maybe some more interesting stuff like running an IDEV session, which we'll talk about later today as well. So history is pretty cool. You can see a lot of that stuff. For instance, maybe we want to see when I did an LS, I'm going to use this another command called grep. And again, these are just going to keep coming, and you're going to use them over and over. Say I wanted to look for every time I did an LS in my history. So I'll do history, and I'll use the pipe, so that we saw this output was just like this, but I'm going to use the pipe and send that to this command called grep and look for instances of LS. And we say, hey, look at all those times I use LS. Man, I do that a lot. I wonder how many times I do that. We could do that, right? Using word count again. So let's try that, and we'll keep growing this command. These are kind of like the one-liners of cool stuff. So I did history. I said there's a look for any time we see LS. Let's pipe that out to word count -L. You say, okay, cool. I typed LS 295 times in my recent history. You can clear your history too if you don't want to have anything in there. You just type history -C. It'll clear everything out so you can start fresh. I tend to let it grow. When I do it on my personal systems, I let my history get really long, so I can go a month back or more and say, oh, what did I do then? How did that work? There's another really cool thing about Bash when using your history. It's called the reverse intelligence search. And it was a very bad programmer who came up with that name. But basically, there's things you do all the time, right? You tend to do one thing a lot. And you can always search through your history by just typing history and looking through all the lines. You could maybe I could do history. It's really long. I could pipe that to less, and I could go a page at a time and go, yeah, okay, I remember doing that. Oh, I don't remember how I did that. Okay, cool. But one really neat thing that you can do is you can use this reverse search where you just type Control-R, and then it brings up this reverse search, and you start typing. Like, maybe I wanted to see, last time I did an IDEV session, we did that, and I can hit Control-R, and it'll cycle through my history of every time it finds an instance of this command IDEV. So pretty cool. When you find the one you want, you just hit Enter. If you didn't find the one you want, you just hit Escape, and you're right back at your prompt. So again, pretty cool. I use it a lot because, again, programmers don't like to type a lot. Some other couple of things you'll want to look at. You can compress files using a program called gzip. Why is it called gzip? Because it's GNU zip, meaning that it's free and open source. And so I have this huge 32K file, massive, tons of text, I'm sure, called big file. And basically I can just zip that file up real quickly using the command gzip. And all you do is say gzip and the file name. And what it does is it compresses that file and then adds this .gz extension so that gzip knows that, hey, I compressed this file. That's what it is. And as you can see, it went from 32K all the way down to 4K. Oh, amazing. Still a huge tiny file. It's kind of nice if you're transferring stuff to your own machine. You're on a slower connection. You'll want to compress it so that it can get there faster. And then, of course, to decompress, which is important, you use gunzip or gunzip, however you like to read it, and you just feed it the file name with the .gz extension, and it'll expand that file for you. A couple of things to note: Linux, Unix versus Windows files. You should never write your code or your submission scripts or really anything you intend to use on Linux in Windows. Don't use Notepad. Don't use Word because it adds a lot of extra characters. Now, if you do use Notepad for some reason, you can use a command called DOS to Unix. Yes, that's how old that command is. And what it does is it converts a DOS format or something you wrote in Microsoft Notepad to something that Linux understands. It's real basic. The only thing that it does is in Notepad, it adds extra control characters at the end of every line, and so this DOS to Unix utility just removes them for you. So pretty simple. If you write a script in Windows, you'll need to do this if you want to run it on our machines. So let's say you are getting ready to move some files around, and we'll do more of this afternoon. But you want to do some file transfers. You can use SCP or rsync. These are the simplest file transfer tools. SCP is, of course, SSHCP. We just add one more character on there. We're still using the original copy command, but now we're piping it over an SSH tunnel. So what I can do here is say I have a file. Maybe I'm on Lone Star or I'm on my other machine or something like this, and I have a file called my file. That's the source. So that's where the file is coming from. And then the next part is the destination or where I want it to go. And I showed you a lot of different ways in the next two slides just to kind of get them all in your brain so you can start thinking about them. So what I did here was I said, copy this file, myfile.txt, over to Stampede. And what I did is I did a little shorthand. I said, hey, just put my username in automatically, and then I'll type in my password when it comes up. So we say, copy my file to my username at stampede.utexas.edu. And the important part here is the colon at the end. If I don't put that colon at the end, this will just think I want to make a copy of my file and call it jlockman at stampede.tech.utexas. And that's what it'll do, right on your same machine. You can use FileZilla as well. Absolutely. This is a nice, easy way to move it around on the command line, so you don't have to open another program, though. If you use the colon on the end, this will say, put it in your home directory. That's what that'll expand out to. For instance, home1, whatever it is on Stampede or whatever it is on another machine. You could also provide the full path if you wanted to do that. So maybe I want to put it in my work directory. It's too big. I don't want to put it in home. I could say SCP, my file. Sorry, that's so small. My name at Stampede, colon, and then I just give it the full directory structure on the other end because I know that that's what it looks like on Stampede. Still copying that? All right. rsync is another option, especially if you have larger files, because the nice thing about rsync is it will continue even if your connection dies. So you can restart a download or an upload. Very helpful if you're trying to move a large file, say from your home internet up to a machine, or the other way around, you're trying to download it, and you just don't have a lot of bandwidth. You know it's going to take a while. I will guarantee you the pipe will break at some point, and you'll be like, oh, I got like half the file, and now I have to start over because I was using SCP. rsync, again, will allow you to resume a transfer, which is pretty nice. The basic, simple way is say rsync myfile.txt to the machine, user at the machine. And again, I did the colon to do the auto expansion to my home directory, so it's just going to go into home. You might also want to do an entire directory, so you'll add a couple of options to rsync, -A and V. And then I said, here's a directory called foo, and again, I used a slightly different one again here. I said, you know what, colon, tilde, and what do you think that does? Any ideas? Think back to when we were talking about my home directory and how I get there. I can use a tilde and a username. What I can do here is I can say, put it in my home directory, colon, tilde, but in a folder called foo. And so it'll create that folder for me, and we'll go from there.
So that's the other things folder. Same time.
Mm-hmm. Yep, it'll create the folder, and it'll copy everything from of the contents from there, in there for you. I don't think I'm going to get through the next section in 10 minutes, so let's give you a little extra time for lunch, and then we'll come back at 1. Sound good? All right.